All right, it's chapter 5 time. We're going to be talking about quadrilaterals here in chapter 5. The first one we're going to learn about, which will carry over into lots of this chapter, is about parallelograms. Before we get going, it is really cold in here, and I apologize for that. Hopefully that won't disturb you. Don't want you to be kept from learning. Anyway, what is a parallelogram? Well, as the name suggests, parallelograms has to do with the parallel stuff. This is the symbol that we're going to use for parallelogram. You'll draw a little parallelogram. It's a quadrilateral with two pairs of parallel opposite sides. So this is, if we're going to name parallelogram NPQM over here, we would end up with these opposite sides being parallel, and that's what makes a parallelogram a parallelogram. Parallelograms then have several other important characteristics. The first one is that opposite sides of parallelograms are congruent. So in this parallelogram here, we got NMQP. The opposite sides, segment NP is congruent with segment MQ, and then segment NM is congruent with segment PQ. Okay, and that will always be the case if you have a parallelogram. Also, in our textbook, this is theorem 5.2, opposite angles of parallelograms are congruent. Okay, so angle M is congruent with angle P, and angle N is congruent with angle Q. So we got a lot of congruent things. We have parallel sides, we have congruent sides, we have congruent angles. Opposite angles are congruent. But wait, there's more. The diagonals of a parallelogram, these are the diagonals. N, Q is the one of the diagonals, and then segment PM is the other diagonals. Well, they bisect each other. So they cut each other in half. So that means if we're going to name this midpoint, or this point of where they intersect, if they intersect at point O, then O is a midpoint then of these two diagonals, and then we can say that segment NO is congruent with OQ, and then segment MO is congruent with OP. Does that make the diagonals congruent? No, it does not. It is not a property of parallelograms that diagonals are congruent. It is true that they bisect each other, however. This next one should not come as any surprise to you once you think about what we got going on here. We have parallel sides. What happens when we have parallel segments and lines? Well, we have angle relationships as well. Consecutive angles, these would be consecutive angles. N and P are consecutive angles. Angle P and angle Q are consecutive, etc. Well, they end up being supplementary. Why? Because they're same side interior angles. So we have all of these relationships here. We have 4 pairs of supplementary angles. And that's just like what we've learned with parallel lines in the past. Nothing unusual there. But these 5 qualities, that parallelograms, opposite sides are parallel, opposite sides congruent, opposite angles are congruent, diagonals bisect each other, and that consecutive angles are supplementary. This is what you have to know about parallelograms. Okay? So this is the lesson. The rest of this is going to be ways that we're going to be using this stuff. Okay, some types of questions you'll be doing is you're going to be solving for x. Well, the first thing, or solving for some variable. In these questions here, well, let's think about what our variable is. Well, if you have a parallelogram, if you're given one angle measure, you can figure out all of the angle measures. What were the rules that we learned about angles? Well, opposite angles are congruent. So if this is 53 degrees, then we know that this is 53 degrees. We also know that if this is x degrees, this is also x degrees. Okay? We could think of the property of a quadrilateral, that all 4 of those angles added together equal 360. But there's a shortcut. There's a simpler way. And that is the last thing that we just talked about. Consecutive angles are supplementary. So if this is 53, 53 plus x has to equal 180 degrees. So x equals 120 degrees. So I don't have to really think about that this is 113 degrees here on number 2, or this is x. If this is a parallelogram and it tells us that it is, these angles are consecutive angles. They have to therefore be, you got it, supplementary. So x ends up equaling 67 degrees. Down here on number 7, our variable expression is not at an angle. These have to do with the lengths of sides. We know this is a parallelogram. Well, I guess it tells us that it is, but it also is marked that way. Opposite sides are parallel. So what has to be true about these opposite sides? That's right, they are congruent. So we can just make a simple equation there and solve. So go ahead and pause the video and see if you can answer the rest of the questions on this page. Potentially, this is no big deal. But as always, if you have a question, put a big star, big circle, or whatever around it, and then ask it. These are the answers you should have gotten, and yes, gasp, we can end up with a fraction. Similar concept going on here on this other side, just a different way of asking it. Now it asks us to find the value of x and then the length of each side. We should know that we have a parallelogram because the opposite sides are parallel. So what has to be true about these expressions? These opposite sides have to be congruent, so we can set up an equation. I chose to do 10 is equal to 2x plus 4. You could have chosen 6x minus, or 7x minus 1 equals 6x plus 2 just as easily. When we solve, we get that x is equal to 3, and then you plug it in. 6 times 3 plus 2 is 20. 2 times 3 plus 4 is 10, and then 7 times 3 minus 1 is also 20. The opposite sides better be congruent, or you've made a mistake. Do the same thing there on number 11. Give it a shot. Okay, these opposite sides, that x minus 3 was equal to 18.5, I hope you found, and then once you plug stuff in for x, you get, oh my goodness, decimals, 23.6. What concept down is numbers, or are numbers 12, 13, and 14 here about? Well, this variable expression is here. This is 130 degrees. Those are angles. These are angles. These are angles. What has to be true about those opposite angles? Opposite angles are congruent. I think you can do that. Solve for A on those 3 questions. Okay. Are these the answers that you got? I hope that they are. The next question is the same concept, really, except we have 3 variable expressions. Keep in mind which ones are supplementary and which ones are congruent. Opposite angles are congruent. Consecutive angles are supplementary. There's a bunch of different ways you can solve for A here. You can set these equal. You can say that these are supplementary, but find A and then plug in A for each of these to get the angle measure. So that is what you do here in 15 and 16. Give it a shot. You should have gotten that A is equal to 12. That makes these angle measures. Finding the angle measures, even if the question doesn't ask you to do so, will help you determine if they're right, because these have to be supplementary, and then the opposite angles have to be congruent. Similar idea on number 16. You should have gotten that A was equal to 6, and then that made angles of 30 degrees and 150 degrees. Now, the concept that's going on here with these questions is that this is asking about PT, TR, QT, and TS. These are the 4 pieces that our information is given about in each of these questions. So those are the parts of the diagonals. So what was the concept about diagonals that we need to remember with respect to parallelograms? That they bisect each other. So we end up with 2 pair of congruent segments. T is a midpoint of both of those segments. Now, what makes the questions that we're about to do difficult has nothing to do with parallelograms and geometry and everything to do with algebra. Let's dig in here. All the questions they're going to do for me are not going to be like this, but these 5 are. So let's work on them. Number 17. Well, first of all, PT is congruent with TR because it's a bisected diagonal, so we can set 2x is equal to y plus 4, and then we can do the same thing with qt and ts. X plus 2 is equal to y. Now, we have two equations with two variables each. This is called a system of equations. We've seen these before. We've solved for these before. You especially did it in Algebra 1. But what do we do with this? Well, we can either solve by using a process called elimination or by graphing, but here we're going to use substitution. How are we going to do that? Well, x plus 2 is equal to y, so wherever there's a y over here, we can replace it with this x plus 2. This is called substitution. This y gets replaced by x plus 2. It creates a new equation for us. Instead of this saying 2x is equal to y plus 4, it's now 2x is equal to x plus 2 plus 4. That y became x plus 2. And now we solve and get that x is equal to 6. Now that we know that x is equal to 6, we could plug that into either of these equations. This one over here is the easier one of the two, and we can get that 6 plus 2 is equal to y. That's how we get the other ones of these. I'm going to set up the next one for you. On number 18, we get that pt is equal to tr. That's 2x is equal, or I'm sorry, x plus 2 is equal to y. We also get that qt is equal to ts. That's 2y is equal to y plus 3. Which variable is by itself? Just happens to be the same thing as what we had over here. That's just a coincidence, really. Y is equal to x plus 2. You'll replace that y right there with x plus 2 and solve. I tell you what, finish number 18 and then do number 19, and we'll call it quits for now. Don't worry about numbers 20 and 21. Hey, I'm assuming that I'll find out if you were listening when you do this, but will you please write, I love pears, but you know what I like better? Bananas. So will you write parallelogram? Well, right there, above that parallelogram. All right, we got tons of stuff going on as we're get going again for this new chapter. Get some rest. Love you, bye.